Okay, so let's have a look at what happens with the structure that looks like this. So I'm going to draw a vertical axis here, and I'm going to make the n as a function of, let's just say this is the x-axis, x. And again, that's usually because I like to have x be along the length of something, even if it might be oriented vertically. But you know, you can picking y or something wouldn't be terrible for that. So again, if we take a little slice here and we look at the free body diagram of this structure, we got 65 on this end, and we got n on this end. So 65, taking the sum of our forces, we got 65 minus n is equal to 0, so n is 65. Positive 65. This is tension. That is not surprising. So I'll draw that out, make that 65 there. And then okay, so that'll be constant until we get to this B point. We want to know what happens at B. So if we take a slice here just below B, again, 65 here, got our N on the other end, and then right above that, we've got these 215 kilonewton forces. So I'm just going to replace those with a single 30 kilonewton force. So again, take the sum of our forces, got 65 minus 30 minus n, move the n over is equal to 0, move the n over to the other side, and we got n is equal to 35. So this drops down from 65 to 35, looks to be about there. And then that stays constant until we get to C here. What happens at C? Let's erase this to give me a bit more room. So at C, we got our bar. All right, again, got our 65, got our 30, and then we got a 60 total, combining those two. And then our n. So again, I'm still going to keep the n pointed directly out of the face, because that solves for me what the sign convention is. If our n ends up being positive, then this thing's under. Then at this point we're under tension. If it ends up being negative, then it's compression. So in this instance, it's going to be negative. So again, take the sum of our forces. 65 minus 30 minus 60 minus 90 is equal to 0. Move the n over to the other side, and we got 65 minus 90 is equal to n, which gives us a n value of minus 25. And that will be constant until we get down to here. So that just leaves us, I guess I need to label my values here. So again, 65 here, 35 here, negative 65 here. So based upon this, I mean, we know we need to get back to 0. So I could go ahead and redo my equations of equilibrium to figure out what the support at D is, or I could just kind of look at it and say, hey, I know that pushing down on the bar decreases the internal normal force as you go down. So if that's the case, then in order to bump back up, we need to push up on the bar. So yeah, that is about that.